Welcome everyone. Another Data Platform Geeks webinar, and this time we have Torres with us. My name is Amit Bansal, and I'm going to be your host. Let's just take 5 minutes and let me introduce Data Platform Geeks, SQL Server Geeks, and Data Platform Summit to you. So way back in 2004, we started off as a small community, so-called user group meeting in somewhere in Calcutta, and we had like precisely 7 members who had joined. This was just a very small get together, and we were talking about SQL Server, and maybe, if I'm not wrong, I was probably demonstrating SQL Server database mirroring. That was one of those new features in SQL Server that time. And since then till date, about 20 years from now, we have come a long way. And of course, I will not take your time to talk about everything that we have done in last 2 decades, but key success has been the formation of SQLServerGeeks.com, the popularity of it, and then the new community Data Platform Geeks, and then our flagship conference. First, it was called a SQL Server Geeks Annual Summit, and then we transitioned into what we call now as Data Platform Summit. And due to the pandemic, since last 2 3 years, we have Data Platform Virtual Summit. And overall, in last 2 decades, we have done countless webinars, in-person events, and 8 years of conference. So this is the 8th year of Data Platform Summit. So a lot of community work. This is a picture which is very close to our heart, the Data Platform Geeks team and Data Platform Summit team. So you can see this is the picture from Data Platform Summit 2019. So that was the last in-person event. And of course, we went virtual after that. And you could see about 1,000 people from 20 countries almost that traveled to this conference. It happened in Bangalore in the Radisson Hotel. And if we compare, what a contrast, a starking contrast from 2004 to 2020, a long way, a long journey. So thank you, all the speakers, all our sponsors, Microsoft, and especially you, the audience, who have had this faith in us and trusted and supported us. Today, as we do our community work, we cater to close to 200,000 people from 108 countries, and they together represent close to 15,000 organizations. So of course, that's a long way. And this has all been very organic growth. When we did DPS, and again, to just show you some numbers, when we did DPS in person, we had people traveling from about 20 countries. But look at this statistics, where we had people from 108 countries when we went virtual. And this completely took us aback. This was totally unprecedented. Some of you already know Data Platform Virtual Summit 2022 has already been announced, and it is free. Anybody and everybody can join, and you can learn for free. We have 5 editions this time. We have the ANZ edition, APAC edition, IST edition, EMEA, and the Americas. And the theme for this year is accelerating data-driven success. And that's why we choose a lot of athletes and athleticism as our theme for this year. So yes, as I said, join for free. So after the webinar, not now, after Dennis is done with his webinar, log on to dataplatformvirtualsummit.com. The first thing you should be doing is book your seat. Along with the regular conference, some of you know, we also do pre-cons, which are 8 hours virtual class that happens before the conference. And we have many pre-cons lined up for you. The slide is not updated. We have 11 pre-cons lined up for you because just yesterday we announced 3 more. So apart from what you see here, pre-cons, the 8-hour virtual class on Power BI Synapse, SQL Server Extended Events, Query Store, Spark, data modeling in Power BI Performance, advanced analytics with Transact SQL, and a special one from Dennis, which is ELT and ETL in the cloud using Data Factory. Apart from these 8 that you're seeing right now on your screen, we have 3 more related to performance tuning in SQL Server. So, and of course, there is a PowerShell for DBA. So those are 3. So go on to dataplatformvirtualsummit.com and book your class. Now, pre-cons are priced. The regular conference is free. But if you want to attend these deep dive classes, you got to make a booking. So only for you, the webinar delegates, you can use this discount code called 60 Steal It. 60 Steal It, and you get 60% off. So take a note of that. I want to take this moment and introduce this pre-con, ETL, ELT in the cloud using Azure Data Factory by Dennis Torres. And that's why he's here today to talk about this subject. And he's going to explain you the concept and show you demos and probably take 5 minutes and talk about what is he going to deliver in his 8-hour virtual class. So friends, special mention for this pre-con. Remember, pre-cons are demo packed, they are live classes, and true value, which is you get the recordings also. We are the only conference on the planet who will give you the recording of the 8-hour virtual class on demand so that you can access the recordings anytime, anywhere, and watch as many times as you want, just for the community. Here, we should be thanking our speakers who allow us to do it. So thanks to all the pre-con speakers who have agreed that their classes get recorded and we can share it with you. As I said, we have multiple editions at DPS. So pick your edition. But remember, when you register, you can actually attend all the editions, any edition that you feel like. You don't have to register 5 times for 5 editions, just one single registration. Again, a huge step towards diversity. We are bringing in multilingual content for the first time. So apart from sessions in English, you will see sessions in 14 other languages, including Hindi, Spanish, Italian, Germany, Slovenian, Hebrew, Chinese, Korean, and whatnot. Totally amazing stuff. Special track on SQL Server 2022 because we are expecting SQL Server 2022 to be released this year. It's already in public preview. Each year for our team at DPS, content is the king. We focus on new sessions, curated sessions, fresh content, and latest updates. We have sessions ranging from level 100 all the way to level 500, which is beginner to brain hurting levels. So explore our content. When you go to dataplatformvirtualsummit.com, the first 2 links on the menu bar, precons and sessions, click on them to explore the content. About 100 breakout sessions for the conference, which is free, is already announced. Even Microsoft sessions are announced. So take a look at that. Huge technology coverage. We are covering about 29 different technologies in Azure Data Stack. In case your company wants to partner with us and become a knowledge partner, you want to sponsor us, most welcome. Just click on the contact us link and reach out to us. So that's it. Evaluate DPS and join us. If you don't want to buy the pre-con class, no problem. Join us for free. But take a look at our pre-cons. Bookings are open, friends. Special thanks to Microsoft for their continued support to our community initiatives. We are all over the place. YouTube, Twitter, LinkedIn, Facebook, Telegram, wherever you are, you can connect with us. A lot of links there in the chat window. Why not just make a note of it, copy it, and put it in your OneNote or Notepad or wherever you're taking notes. Quick housekeeping notes. You are so well versed in the digital world today, so just make sure you're using headphones so that you get best experience. We are on Twitter, the second last bullet point, Data Geeks, SQL Server Geeks, and I'm available on _Bansal. Feel free to tweet your experience, help us spread the word, and give feedback after the webinar is over. With this, we hand over to Dennis. Dennis, thank you so much for joining us today, and thank you for taking our time to deliver this webinar for the Data Platform Geeks community. Over to you.
Thank you.
So you can share your screen now, yes?
Is this screen visible now?
Yes, it is.
Okay. So let's start. My name is Dennis Torres. I'm a data platform MVP, trainer, data engineer. And today we'll talk about building data pipelines with Azure Data Factory. So the main focus is the Azure Data Factory and some techniques about data pipelines and why we need them and so on. So this is me. I'm a data platform MVP. You can see my contacts. Feel free to get in touch. It will be a pleasure to stay in touch. By the way, let's say an advice. In many sessions like this, sometimes I include many links in the middle of the slides and do not have time to copy the links on the chat immediately. So it's a good idea if you can use Windows Shift S to capture my screens. I sometimes, when I watch some sessions, I use Windows Shift S to capture his screens and I paste in PowerPoint, for example, immediately and continue watching. Then I take a look on what I capture later. So capture some screens using Windows Shift S is a good idea. Okay, some important details. One was this one, the use of Windows Shift S that I really recommend you to capture some links that I included during the session. Uh, Another one, I'm with a small flu. I'm sorry if I don't speak fast enough, or if I'm speaking slowly or something like that, because I'm with a small flu and I'm not sure how this will affect my speaking. And this is my pre-con session. It's about ETL and ELT in the cloud using Data Factory, an 8-hour training about Data Factory. So, in some ways, this 1-hour training is an overview of what Data Factory is capable to do and why we would use Data Factory for some tasks. But in the pre-com, we'll get deeper on this. Many of the demonstrations that I'll show today, I'll get some already built pipelines and analyze these pipelines with you. During the pre-com, we'll build them from scratch. So we'll have more time to see details about building these pipelines. So our agenda today. What's Azure Data Factory? Building a data warehouse, the date dimension in the data warehouse, the product dimension. This is focused on an example that I will start to illustrate. And let's start talking about what is Azure Data Factory. It's an evolution of SSIS. What's SSIS? Well, the oldest one in the call may remind that SSIS was created in SQL Server 2005. SQL Server 2005. It is a very powerful ETL tool. Very powerful ETL tool. And even so, it was created in SQL Server 2005. Before that, since SQL Server 7, we had a previous tool called DTS. It was older, not so powerful as SSIS, but the idea was the same. The main idea here is to build an ETL process with a minimum of code. No code, low code technique, building an ETL process using a no code, low code technique. That's what SSIS was. It is because it still exists. And that's the idea of Azure Data Factory now to the cloud, to build an ETL process with minimum code. So built for the cloud, we use Azure Data Factory in the cloud to make cloud ETLs, low-code ETL, ELT solution. And let's talk about the basic elements of Azure Data Factory. What we need to build inside Azure Data Factory and what are the elements inside Azure Data Factory. First, we have the pipelines. What is a pipeline inside Azure Data Factory? For the ones who know something about SSIS, the pipelines resemble the SSIS control flow. The pipelines, they orchestrate the execution of the transformations that we will make during our ETL. So it's a control orchestration for the transformation that we will execute and resembles the SSIS control flow. And the data flows. The data flow is intended to be one transformation. We specify one specific source on the level of a table, for example, and then we build the transformations of this data, the transformations of this table, and save this data to one specific destination. So the data flow is one specific transformation built over one specific set of data. This resembles the idea of the SSIS data flows, the data flows that we had on SSIS. When we decide to build an ETL, to build a data warehouse, for example, it's very common that we will need many data flows. For example, we are building a star schema. We'll need a data flow for each dimension on the star schema, and you need a data flow to the fact table, for the fact table on the star schema. Okay. And who will orchestrate the sequence of execution of this data flow? Is the pipeline. The pipeline will orchestrate the execution sequence of these data flows. And then we have linked servers. We are in the cloud. We are using the Azure Data Factory, and Azure Data Factory needs to access data sources and data destinations, where the data will come from, where the data will go to. Each source or destination is hashed in the data factory as a linked server. We hash these servers as a linked server. It's an external source of or destination. The linked servers use um, integration runtime. The integration runtime is used to execute the load of data from that data source or the saving of data to that data source. The integration runtime used by the linked server can be an auto-generated integration runtime or a self-hosted integration runtime. What this means, a self-hosted integration runtime? Well, if everything is in the cloud, source, destination, everything is in the cloud, Data Factory is able to access everything easily. So the auto-generated integration runtime will work fine. But what if Data Factory needs to get data from on-premise environment, for example? You need to load data from the on-premise environment. How will Data Factory access the on-premise environment? In this example, you need to install in an on-premise machine what is called a self-hosted integration runtime. You install a self-hosted integration runtime. This integration runtime will integrate with Azure Data Factory. When you hash the linked server pointing to on-premise, you point the use of that self-hosted integration runtime. And then Data Factory will be able to communicate with the on-premise environment through the self-hosted integration runtime. And we have data sets. Data sets are used to gather the data flows. They are the schemas that are defined as source and destination of the data. So we use data sets as source of the data, and data sets are as destinations of the data. The data sets, they are related to the linked server. Every data set needs to be hosted by one server. It's hosted somewhere. Where is this data set? So the data set needs to be hosted somewhere. Where is this data set? So the data set needs to be hosted somewhere. needs to be hosted, set to define the source and destination. And as a consequence, you'll be using linked server as well. And the pipelines will orchestrate the execution of the data flows. So these are the main elements that we'll be working with on Azure Data Factory. Let's take a look of these basic elements first to recognize what we have in the Data Factory environment. Then we'll start to talk a bit pipeline transformation. So when we provision the Data Factory, we have this initial environment. But to really develop a Data Factory pipeline, not one, but multiple Data Factory pipelines, we need to use the Azure Data Factory Studio. The Azure Data Factory Studio. So I have here the Azure Data Factory Studio. And I can take a look here on the linked servers. I have two linked servers, two SQL servers are being used here as linked servers. One called Adventure, another one called DPG SQL. So I have two SQL servers being used as linked servers. I have the access to both of these SQL servers here. The one called Adventure is providing access to the Adventure Works Little. Is a small database, sample database, but it can be increased a bit, and I did. I increased this Adventure Works Little a bit, and it's using big product, big transaction history. We will use these tables in our example. And the destination is the DPG warehouse, where I built some tables. I have here 2-dimension tables, date dimension, product dimension on the destination warehouse. The purpose here using the data factory is to make the flow of data from the production environment to the data warehouse. Ensure the flow of data from the production environment to the data warehouse. Getting back to the linked servers, when we take a look on the configuration of the linked servers, I'm not being very detailed here in relation to security. I have not configured many details related to security that I could have configured. For example, here I'm using a username and password authentication using a SQL authentication. What options could I have? What options could I use here? First, I could be using key vault. Instead of using the password here, I could be using key vault and reading the password from the key vault. This would be way safer. That's one option. Another option is if I set a managed identity for my data factory. I could use a managed identity from my data factory, give permission to this managed identity on my Azure SQLs. And by doing so, I could choose to use a managed identity authentication to Azure SQL. This would be way safer. Way safer. Not that SQL authentication is not good, but there is no doubt that the managed identity is way safer because the authentication in this case is happening with Azure Active Directory. And this is just the beginning because, in fact, my two Azure SQLs, they have a public endpoint. I could configure the two Azure SQLs with a private endpoint. and also configure the data factory to work with the two Azure secrets using private endpoints. And all the transformations, all the communication would be completely private. These are some details about security that we need to take care when using a tool such as Data Factory. These are general Azure network knowledge, and we need to take care when using all kinds of tools, especially and including a tool like Data Factory. Okay, I have not went so far on the configuration related to security here, but we are seeing the two linked servers in this example. Then if you go to auto, I have some pipelines that I already built. I will go in details on these pipelines in some moments. I have data sets which I'm using to lower the products dimension, lowered the products dimension to our data warehouse. But the dataset doesn't do this. Who does this is the data flow. The data flow lowers the product dimension to our data warehouse, and the data flow uses the dataset. And each dataset is linked to one linked server. Each of the dataset is linked to one linked server. In this example, one linked to the source, another one linked to the destination linked server. Okay, so this is a small idea about the objects we have around in relation to data factory. So, why the data warehouse? I'm talking and I'm going to ask the building of a data warehouse. I'm going to build a data warehouse using Azure Data Factory. There is a question here. Can I use one dataset to connect two linked servers? I'm not sure if I completely understand the meaning of the question, but each dataset needs to be linked to a single linked server. The dataset belongs to one linked server and only that linked server. But you could use datasets. For example, one dataset linked to the source, one dataset linked to the destination, and in this way transfer data from the source and destination. In fact, this transfer is the task done by the data factory. This kind of transfer from one source to one destination using the datasets related to the linked servers. I hope this has answered the question. If not, please give me a feedback, add more details about the question, and they will help. So, I was talking that I was about to start the building of a data warehouse, building a data warehouse using Data Factory. There is a lot of theoretical details in relation to this, because many people may think, oh, data houses is still something from last century. Why we are not using data lake? We need both. We need to have both. We need to have data house. We need to have data lake. The tools used to build a data lake, they are different than the tools used to build a data house. Both tools are different. Data factory can be used for transformation inside a data lake, but it's not really the main tool used in a data lake environment. It can be used for transformation in a data lake, but it's not always the main tool there. But it's always the main tool on a data warehouse. That's why I'm starting with a data warehouse example. Uh, About how to set manage identities in Data Factory, there is no mystery. There is no mystery. In fact, it's just about turning this on. Once I turn this on, the name DFDPG, which is my data factory, this name is already an Azure Active Directory user. And being an Active Directory user, this guy, the FDPG, can get permissions inside our Azure SQL. We can give permissions to this guy inside our Azure SQL. And then when connecting to the linked servers, we choose to use the managed identity instead of specifying one SQL Server authentication identity. So we choose to use the managed identity, and we'll be using the permissions this guy has over our Azure SQLs. Yes, the source can be a custom SQL that joins multiple tables. In fact, I did this. In my examples on the pipelines, I did on the pipelines and on the data flows, I did this. You'll get there and you'll see that there. But there are some interesting details. I'm not completely sure I'll have time to talk about these details. If you take a look on my blogs on Simple Talk, I wrote a blog about this. How to run a custom SQL in Azure Data Factory, because the UI is not so simple, so direct for you to run a custom SQL in Azure Data Factory. The UI is not so direct for that. So I wrote a blog post about this, and in this example that I'm about to show, I used this. I used custom SQL with joins and so on. So we were talking about why the data warehouse. We need a single source of truth. Every company needs a single source of truth. It would be a completely mess if every report that the company is generating starts to appear with a different number. Does anyone have this kind of experience? Reporting is starting to appear with a different number. This would be a completely mess. This would be absolutely terrible, something absolutely terrible to happen. So we need a single source of truth. And this single source of truth can be our data house. Our data house can be the single source of truth. And it needs to be technology independent, not totally technology independent, but as most as possible, technology independent. For example, a few days ago, I was talking to a customer, and the customer was complaining to me that inside his company, there were some fights between some departments because some departments like to use Power BI, while other departments like to use Tableau. And then they end up duplicating everything between Power BI and Tableau. How to solve something like this? That's one of the reasons why many people will say this is my specific opinion, but I defend this opinion a lot. I believe the data house needs to be isolated from this technology. The data house needs to be a SQL database. A SQL database will be the data house. In this example of two departments fighting because one wants to use Power BI, the other wants to use the Tableau. Okay, let each one use what they like to use. But the company still has a single source of truth, which is the centralized data house in a SQL database. SQL or Synapse, if it's too big, it would be Synapse, but that's another story. The point is, the data house is in a centralized point, And the specific serving tools can be anyone that the departments would like to use. The departments can build from the data warehouse. That's where it starts the idea of self-service CPI. Business focus, not app focus. Usually, many people don't understand why do we need to transform the schema when we move to the data warehouse. Because probably in production, you have many different applications. You have an application to control sales, another to register customers, another to control stock, and the applications sometimes are independent from each other, very independent from each other. So each application has its own database. The database most of the time don't match, and you need to create a single source of truth for the company. So you need to get all this data and join this data inside a single place. That's what Data Factory can do for you. And this involves a transformation of the schema. You get the schema from the sources and transform this schema to become a centralized schema for a data warehouse. Integrating all the data from the different business applications and optimize it for reading. The optimization that you require in production environments is different than the optimization that you need in a data warehouse. In a data warehouse, you optimize for reading. In a production environment, you need to optimize for transactions, for the transactions that are coming. But in a data warehouse, you optimize for reading. So the optimization is different. This completely changed the idea of the model. So you need to transform the model when you move your data from production to the data warehouse. For example, a classic data warehouse solution, data sources. Then you have the ingestion, and here is where data factory takes place, ingesting data. Then you insert this data. I'm calling here a data lake house because it's a data house, but as a single source of truth, you could be working with a data lake as well, but that's another story. From here, you create data models, also called as cubes, or some people call as semantic models, and then you create reports and dashboards to analyze your data. Where Power BI gets in this area? Here. The semantic model is built by Power BI. The reports and the dashboards are built by Power BI. All these are built by Power BI, but we have a data warehouse behind the scenes being the single source of truth for the company. If a different department decides to use Tableau or Quick instead of Power BI, they can. Let they do it. Let they do it, and your single source of truth is insecure, accessible by many different tools. Uh, there is a question here about moving on-premise SQL DW database into Azure SQL database or Azure SQL Data Warehouse. First, you need to know that Azure SQL Data Warehouse is deprecated. This tool doesn't exist anymore, not with this name. Azure SQL Data Warehouse became Synapse Analytics. Is in fact one tool inside Synapse Analytics. And the difference, if you move to Azure SQL Database or you move to Synapse Analytics, is the size, the power of processing that you need for your data, the amount of data that you have. If you have a very small set of data, a simple Azure SQL will be enough. But if you have a huge amount of data, that's when you need Synapse Analytics. And I included this idea here. Don't be this guy. The image is talking about AI and machine learning, but I'm talking about this in relation to data factory, ETL, and the build of a data platform. The idea is you need to know the basic concepts to build a good data platform. You need to be working with the basic concepts for that. Some recommended reading. Uh, Windows Shift S, chapter the screen. These are two articles that I wrote, and they talk about architecture and they start discussing architecture. This is not only about reading. Don't limit yourself to only reading these articles. I would like to read comments from you, other possibilities, to ask questions about other possibilities, and so on. So I would like to discuss more about the architectures on this article because there is nothing like one size fits all. This doesn't exist. This doesn't exist. Although on my sessions I'm guiding you towards one direction, this doesn't mean that other directions would not work for a specific scenario. They would. Yes, it's possible to implement incremental data load in Azure Data Factory. Let's talk a bit about this. It's included in one of my samples. So this is the source database that will be loading and eventually works later. The example is not intended to be complete in this 1 hour session. This example will be beyond complete during our pre-con later. But now, on this 1 hour session, this is intended to be a small glimpse of what you'll see later and an initial idea of the data factory. So, this is the Adventure Works Layer, and I'll get this information, build the style schema. The transactions will be in the middle, and they'll build the customer dimension, a product dimension, and a date dimension. So I have transactions. Big transaction history is the transaction. I have big product. This will be the products dimension. But not only this, big product has relation to product model. I have here product model. I will not take product model and big product to the data warehouse as two different tables. That's not how we do. I join the information, big product and product model, and I build one dimension, product, to be used to classify the data of the transaction. The same happens with customers. I have customer his and I have customer address. The customer address contains the location of the customer. Where is the customer? In which country, in which state is the customer? In fact, there are three tables: customer, customer address, and address. And so I can join these three tables and take these three tables to the data warehouse as one dimension, customer. So see, this kind of transformation is transformation that we need to do between a production environment and a data warehouse environment. We need to make this kind of transformation. Let's start talking about the data dimension. The data, sorry, I wrote it wrong here. The data dimension. Calculations are needed. Calculations are needed in the date dimension. For example, we have a date. Okay. But from this date, we have the day, the month, the year, the day of the week, the day of the week, the day of the year, the quarter inside which that date is, and you need to calculate all this. And one rhetorical question here: should we leave the workload? Should the workload of these calculations be on the query, on the moment we are querying the data dimension, or on the loading process, on the moment we are loading the data dimension? The data warehouse needs to be optimized for querying. I saw one question about Synapse. I would like to answer that in a moment. I would be answering that in a moment. But now it disappeared from my window.
Yeah, it's there, Dennis. I'll read it out whenever you want to answer.
Okay. Is it about difference between Azure SQL and Synapse?
Yeah, how different is Azure Synapse from Azure SQL Data Warehouse for building BI and data warehouse use cases? Synapse architecture still keeps the old Azure DW architecture, or some features changed? That was the question.
The changes are on the underlying architecture, how Synapse processes the data, and this gives a huge processing capacity to Synapse. Synapse uses an architecture called massive parallel processing. You think you build a database in Synapse, but each database you created in Synapse is in fact underlying the scenes 60 database. You create one database, you are creating 60. And Synapse will process that in parallel in a way that Azure SQL don't even get close to do. So it's extremely powerful processing platform. That's the point. So that's the point related to the difference of Synapse. Let me highlight that there is a video about this. There is a video about this on my YouTube channel. If you go to my YouTube channel, you'll find some sessions that I delivered explaining in details how Synapse works. There is a playlist called Conference. There is a session there about how Synapse works. I think I'm a bit delayed. Should I stick very closely to the end time, or could I pass a bit?
We can extend a bit, no problem.
We can extend a bit. Okay. So the question about the slowly changing dimension type 2 using ADF. I have an example about this. Let's see how I can get there. I have an example about this. It's difficult to know that use data factory to orchestrate Azure Databricks notebooks as a best practice. Data factory can include notebooks inside the pipelines. The notebooks can be included inside the pipeline. But I would use the notebooks when for some reason a transformation that I'm trying to achieve is becoming too difficult to achieve in a no-code, low-code scenario. Then I will make that transformation in a notebook and include the notebook together the pipeline, while I keep all the rest as no-code, low-code. But if you are building everything using Azure Databricks notebooks, why I'm not sure why you would use Data Factory to orchestrate them. I'm not sure if that would be a good practice, but it's a good practice if you have one specific transformation that needs Databricks, needs Python code, and you can put a notebook inside Data Factory. You can do that. Okay. So the point here, I was talking about how the calculations for the data dimension the calculate for the data dimension needs to be on the loading process and not on the query processing. That's why we need the data dimension with all the data calculated on the data dimension. So we need to build the data dimensions with everything calculated. Persisted calculated columns provide a great help for that. And the data dimension needs to be always up to date. If our data is receiving more and more transactions, according to the time advance, we need to be sure that our data dimension has date records representing each day of our transaction. They need to be there. So our data dimension needs always to be up to date. Let's see an example related to data dimension. I will illustrate an example about data dimension. Data dimension table. This is a data dimension table. DIN date. Take a look about how many fields are included as calculated fields inside the table with a data dimension. All then are included as calculated fields. Most of them are included as calculated fields. And not about calculated, but persisted. If I include only as calculated, the workloads you calculate then would be on the query side. That would be bad. So including calculated field, I need to include as persisted. And there is a technical detail about that. The functions that I use for the calculations need to be deterministic functions. If for some calculations I need to use non-deterministic functions, then I can't include them here because they can't be persisted. If I include as not persisted, they would put load over the queries. So that's not a good idea. So this is a table for the data dimension. And then I have here a stop procedure to fill this table. The stop procedure receives two dates, start date and end date, and executes a loop to fill the data dimension. It needs to fill only the fields which are not calculated fields. All the calculated fields will be filled automatically, filled. So all the calculated fields will be automatically filled. I need to fill only the ones which are not calculated. Okay, let's make some queries here. Select count star from DIN date. The date table is already filled. I will truncate this table, truncate table DIN date. And I will explain how I built the pipeline to fill this table. How did I build the pipeline to fill this table? Build date dimension. There was a question there about automating the deployment of Data Factory. I'm not talking too much about this now, but Data Factory can be integrated with GitHub, with a Git repository, and we can even integrate DevOps techniques for the deployment of a Data Factory environment. These would be some more advanced scenarios, but we have features for that. So, what's the point here? I want to build the data dimension. Okay, I want to build the data dimension. To build the data dimension, I need to understand if the data dimension is already filled or not. So I need to make a query to the data dimension and identify the start date and then date on the date dimension. If the date dimension is not filled at all, then we will receive null in this case. We will receive null on these variables. These are outputs for an execute script. An execute script executing a query over SQL to get the minimum and maximum date, returning output parameters. I'm setting the output parameters to a variable, and then we can work with that. And I need also to get the real start date and real end date, which is from the transactions table. My date dimension needs to be covering this period in the transactions table. And in fact, on the real start date and real end date, I made the calculation to get the minimum date and subtract 1,000 days and the maximum date and add 1,000 days to get some room for new records. I need to leave room for new records. Then the set final start date and set final end date makes a definition depending on if the date dimension is empty or not. Is a set of nested ifs. I can use nested ifs in an expression. In a pipeline, I can use nested if in an expression to define a variable. And I'm using ifs to check if the data dimension is empty or not. If it's not empty, is it covering the date that it needs to be covered, or it's not covering the date that needs to be covered? So I define the final start date and final end date. Would I be covering DevOps with ADF in your pre-con? I'll be covering the use of GitHub, not a complete DevOps scenario, because this would take a lot of time. We would miss time for building the pipelines, but I will be covering the integration with GitHub. Yes. The pre-con will cover the integration with GitHub. And then we have an if here. This if is testing if basically what I need to do. Is the date dimension empty or not? If the date dimension empty, I need to call the stop procedure just once to build the entire date dimension with the date calculated before. It's a call to the stop procedure. Just a call to the stop procedure. If the date dimension is not empty, then I need to make some additional checks, and I created another pipeline to make additional checks. I'm passing to the other pipeline and calling a second pipeline, passing some parameters to the second pipeline. And on the second pipeline, I receive the parameters and I make some checks. What can be happened here? The date dimension is not empty. There is a set of dates here, but maybe the date dimension may be missing some dates in the beginning. Maybe some old records were included in the table and the date dimension needs to have the dates to cover those records. This is not something often, but it could happen. What would be most common is the date dimension to be missing dates in the end, because according to the time, we will reach the limits of the date dimension. You need to add more records to the date dimension. This will be the more common task. So I make a calculation with the date and call the stop procedure There are two calls related to store procedure depending on the if. If there are missing dates in the beginning and missing dates on the end, the calls to the store procedure will happen. So getting back to build date dimension, we can see that our date dimension at the moment is empty, and I can execute here just calling the debug option. And it's interesting how Data Factory evolved from past versions. I can now call the debug option and I will be seeing the execution. Here is already showing these execution steps. On each execution step, I can see the input and output of each execution step, what came in, what came out. The if is starting was executed, then it's calling the stop procedure build dating because my date dimension is empty. My date dimension is completely empty. So it's executing the stop procedure to fill the date dimension. It's done, executed successfully. If I query the date dimension, 4047 rows. And I will run a bit because we are already over 1 hour, but there is one interesting question that was asked. How to make incremental load? Is more than only to make incremental load. It's about to manage what is called slowly changing dimensions. Slowly changing dimensions, type 1, is the dimension, for example, product. You just overwrite the data of the product. The product was updated in the source, then you just overwrite the data of the product. I don't like this option. I believe this option is absolutely terrible. It may work for small scenarios. If you build your data warehouse to focus in one specific result, you may believe this will work for you. But you are missing information. For example, what if the price of the products change? You need to relate the fact the fact sales, with the product record when that sale happened. So according the price of the product changes, you need to make a correct relation between the fact and the product. If you don't make this correct relation, how would you know that the sales are going down because you increased the price of the product? How would you find this information in your data? You would be missing that. So we have the type 2. The idea of the type 2 dimension is slowly changing dimension is to keep everything. Every time a record changes, we keep a history of that record. That's why my product table in the data warehouse has the original product ID, but the original product ID is not the key of the record anymore, because I may have many records of this product ID. Every time this product ID changes in the production, I will have a new record. This table is keeping a history of the record. I included here a field called end date to keep a history of this record. A new product key, this product key only exists in the warehouse to be the real key of this record, because the product ID itself will repeat many times. And how will we identify the changes? There are many methods to identify the changes. One of the methods to identify the changes is to enable change tracking. We can enable change tracking in the tables, in the source tables. And enable change tracking, we are able to identify the changes that happen on that table. And in this way, we'll be making not only will not only be solving the incremental loading problem, but we will also be keeping a precise history of what happened in our data house. If you don't use this, you'll be missing data. You'll be throwing data away and missing opportunities of analysis. And that's bad. That's very bad. Options that you have to manage these, let's say incremental loading. Change tracking is a SQL Server feature that you can use for that. CDC, called change data capture, another SQL Server feature you can use for that. I already used it in a distant past, manual tweak using timestamp fields. You put a timestamp field and you can know what records were changed after last time you captured the information. And you can build additional custom solutions with fields like modifier date and so on. You can build additional custom solutions to make this kind of change tracking. Um, Santosh made two questions. The first one, I'm not completely sure. I will need to give you a feedback later, but I believe it supports. Does Synapse support schema binding views? I believe so. I believe so. Schema binding views. But please follow up this question with me on my email. Logical partitioning or Hive partitioning with loading data into Synapse. There are some partitioning tricks in ADF to optimize the performance, but I'm not sure if that's what you are asking. I will need an additional explanation about this question. Please follow up this question with me. The slowly changing dimension is a technique that applies to any kind of model. Slowly changing dimension applies to multi-dimensional models or tabular models. It doesn't matter. It doesn't matter. In fact, we are not even talking about the semantic model yet. Because when you talk about multidimensional or tabular, you are talking about the semantic models. We are not there yet. We are talking first about building the data warehouse and later about building the semantic model. And they could be used in both. Okay. So let's give a fast glimpse about the product dimension, how the product dimension is built. I need to decide about get the last version. This script is get the last version from a table that I created. I created a table here called SCD control. This table SCD control will always hold the last version that I already loaded about one table, from one table. I need to get the version number that I loaded and insert in this table called SCD control. So I use to control the load of the slowly changing dimension. And here on my example, I'm making the load of the information of the last version, which can be null. And if it is null, I need to load everything. If this information is null, I need to load everything. That's a difference that this if is analyzing. Is the last version null or not? If it's null, then I'll build a full cycle to load everything. The cycle will be just to load all the data. Just the cycle to load all the data. And I'll need to insert a new record in the SCD control table with the new version control. I'll need to insert this new record on the SCD control table. Okay. And in the other case, in the other situation, the SQL will use some features from change tracking. In this case, I use some features from change tracking. I'm sorry, this SQL is not correct. I need to fix that. And I would be updating the value of the latest version. I have here the difference on the SQL's product queries. Here. The SQL to load everything would be this one. The SQL to load from one specific version, starting on one specific version, it would be based on this one. I need to add a new where here. This last part is not complete. I was finishing this part just before the session. It's not totally complete, but it's giving a good idea about how the SCD works. We have a SQL to load everything if we haven't uploaded anything yet, or we can get the changes from the change table and load only the changes to our model. And then when we load only the changes to our model, then we have here a data flow, products data flow. I insert the records of the products with a new end date. This will be the new active product. And I make an update to the existing product records, disabling the existing product records. So I disable the past product records and create a new active product record in the slowly changing dimension. Without this, we are seeing a glimpse of how this is built in Data Factory, what is possible to show in more than an hour. I already took about 1 hour and a half here. But in September, we'll have the opportunity to have 8 hours to study these pipelines and build these pipelines from scratch. And not only these pipelines to build the data house, but even more. I will show some more advanced examples, including examples with cognitive services and so on. So Santosh explained better the question about partitioning. He is asking about partitioning in a data lake, partitioning the data in a data store in a storage in a data lake storage, and partition the data according to the folders. Yes, it will support it. It supports this kind of partitioning. It supports this kind of partitioning, but the support is not on ADF. The support is on Synapse. We can connect from ADF to a Synapse serverless and make a query that is filtering the data in the data lake by one specific year, and in this way making partitioning. So we can make this connection to Synapse serverless and using the partitioning filter in Synapse serverless. The feature is there. In fact, this partitioning feature is evolving. It is evolving more and more. More tools are supporting this partitioning feature. I'll not talk too much about this because I don't fully remind what is under NDA and what's not. But a lot of new tools, SQL tools, are supporting this level of partitioning. The task of ADF in this case will be to connect to these tools and make the query using the partitioning feature that the tool has. In this example, Synapse. Connect to Synapse and use the partitioning feature in Synapse. Does this explain the question? Great. So, thank you very much for attending this session. So we talked about the basic concepts of data factory, a data warehouse, data dimension, and an SCD type 2 dimension. Some links from the data platform GIG, YouTube channel, and so on. Remember to capture these links and my contacts. And I mentioned that there were some questions about Synapse, the difference between Synapse and Azure SQL. On my YouTube, there are videos of previous conference that I delivered talking the difference between Synapse and other SQL tools. So you can take a look on my YouTube channel and see this difference. So thank you very much for attending this session. I hope you enjoyed what I illustrated today, and I hope to see you all on the pre-conference. We'll have a lot of time to go really deep on building a data house and even integrating with additional features like cognitive access, making sentiment analysis with Twitter and so on, all using Data Factory.
Thank you so much, Dennis. And friends, there's one thing we ask from all of you, which is feedback. So please do not skip this. Please give your feedback. The link is there in the chat window. We love to hear from you what went good, what went bad, and how we can improve. So just a few words from here. The link is there in the chat window. Just click on it. It takes you to LinkedIn where you can give your feedback. And I'll take another opportunity here to talk about Dennis's pre-con at DPS 2022, which is ELT in the cloud using Data Factory. So if you are keen on a deep dive 8-hour class, and remember, you're going to attend live. And even if you're not able to attend live, you still get the recordings of the class either way. So make it you are able to attend this. The discount code is 60, steal it. Do not miss. There are many other pre-cons that are there which might interest you. The biggest advantage is if you are keen on multiple pre-cons, you can book as many as you want because you get recordings for all of them. So Dennis, what exactly are you going to cover in your 8-hour class? Could you just spend 2 minutes talking about that?
Yes, in fact, what I displayed today is a small glimpse of that. I talked about the theory of the data warehouse, why we need to build things using specific format, why do we need to transform the data. We'll be talking this on the pre-con as well. And these pipelines that I showed already built, we'll build from scratch on the pre-con. We see how to build them from scratch on the pre-con, And even more, we'll complete the star schema scenario that I illustrated, and even see how to integrate with other tools in a data lake environment, sentiment analysis in cognitive services, and other environments as well, building not only a data house, but the idea of a data lake house.
Okay, perfect. Thank you. Thank you so much, Dennis.
And there is one other question here on the chat. I would like to answer this one.
Sure.
It's asking about, is Azure analysis services for multidimensional model or for tabular model? So it's talking about analysis services. Analysis services, when it was born, it was in SQL Server 7. It had only the multidimensional model. Then in SQL Server 2012, it got the tabular model, and we had the option to choose between multidimensional model and the tabular model. We had this option to choose. But when analysis server went to the cloud, it went only with the tabular model. The Azure Analysis Services has only the tabular model in the cloud. So today, if you want to use multidimensional model, you need to use a SQL Server on-premise or an Azure SQL VM using analysis services in a VM. And in relation to this, I wrote some articles in Simple Talk. You can take a look on my blog on Simple Talk. There are some articles that build a data dimension in the tabular model and in the multidimensional model. And this is very useful to compare both models. But today, everything is going towards the tabular model. In fact, even Azure Analysis Services is being integrated with Power BI. Power BI, officially from the point of view of Microsoft, Power BI is a superset of Azure Analysis Services. And both of them work with tabular model. So everything is going to tabular model. The multidimensional model can only be used today in on-premise virtual machines and may at some point become deprecated.
Perfect. Thank you, Dennis, for answering all the questions and for this wonderful content. Friends, all of you, take a moment to give feedback. And once again, we look forward to seeing you at Data Platform Virtual Summit 2022. Go to dataplatformvirtualsummit.com and sign up today. Thank you. Thank you, Dennis. See you soon.
True.
Goodbye.
Welcome. See you soon. Bye, everyone. See you soon.